I've been doing my job in the client space for a while, and one of the things that we were doing 5-6 years ago is we get a new generation of PCs. IT would do its thing to us, we'd deliver it to the employee, and every year their experience got worse. So they come and say, what did IT do to my PC? I can go down to the store and buy something and it's going to perform wonderfully. There were a couple of things that were really crippling the PC. IT had a reasonably heavy load on the PC with our security software. We were moving to whole disk encryption. And in addition, we were running into our highest failure rate on the hardware itself was the disk drives. So when we say employee demand here, what we're really talking about is they demanded a higher performing PC than we were giving them. And the way that we really addressed that was with SSD. We saw an opportunity as SSD started coming to market that would go into the notebooks to really move towards that no moving part device, which we've been talking about for years. The key drivers for us, we had hard drive reliability issues. That was our number one failure item on the PC, and it was pretty disastrous when it happened. Client performance, as I indicated, we had a reasonably heavy application load on the PC itself. And when we put SSDs in these, all those things went away. And again, encryption performance was a big part of that. We were moving to a whole disk encryption-based world to protect our intellectual property. Our attach rate was relatively low. Employees actually couldn't get their work done on their devices. And SSDs enabled that and got us to almost 100% compliance on our encryption on our PCs. Now, from an IT perspective, that's all great. We had happy employees. They wanted the stuff we were giving them. But we also are a numbers-based organization for a lot of things, and we're held accountable for total cost of ownership. And as we started this in the early days, we were looking at, well, how are we going to pay for the cost of these SSDs? It was pretty significant at the time when we started a few years back. But we went through the analysis, looked at the failure rates, looked at the stability of the devices, looked at the resale value of the devices, and we came to a pretty quick conclusion that going with SSDs, even when they were higher priced, was the right thing to do. And our employees supported us with that wholeheartedly. So for the first time in many years, a couple of years ago, as we started handing out the PCs, they were going, wow, this is faster and better than anything I can get going down to the store. We adopted it. Initially, we were retrofitting PCs as they came in, but we were hitting the start of a pretty heavy refresh cycle. We have about 90,000 laptops in our environment, and we refresh at about 25 to 30% every year. And so as we move forward the last couple of years, refresh has been a major element of deploying our SSDs. And when we paired it together with our operating system upgrades, we kind of killed a bunch of different birds with the same stone, so to speak. Hopefully no bird lovers here. TCO is total cost of ownership. So the financials around, does this make sense for us to invest in this technology?
When you say refresh, what does it mean here?
Okay, so PC refresh for us means we have a fleet of about 93,000 PCs, laptops, and we have a more or less regular refresh schedule. After 3 to 4 years, they're falling apart, or they don't meet the performance requirements for our applications, and we go and take the old PC and give them a new PC. So we do that on a regular cycle to maintain a good total cost of ownership and a good user experience. We're about 100% deployed in our laptops. There's very few reasons not to take the SSDs that IT's offering, unless you need like massive super duper capacity. And we're still targeting some of those for SSDs as well. We have pushed it across, to give you an idea of the complexity here, we've got three different form factors of SSDs in the environment today. 2.5, 1.8. SATA. We have different capacities. That's one of the things that we've been managing and adjusting and working on figuring out what the right amount of capacity is. And so we got three different basic capacities, 80, 120, and 160. 5 different product families, so there's a technology refresh of SSDs every year or so, where there's a new generation of SSDs that offers new capabilities. And we do this across our whole fleet. We've got about 64 some-odd laptop models over a 3 to 4 year period that we deploy. So we've got a very heterogeneous environment there. Been through a number of firmware versions, 2 different encryption methods with holdless encryption and now hardware-based encryption. So it's been a relatively complex environment that we've been deploying to. But at the end of the day, it's very doable, it's very manageable, and it's paid us huge dividends to do this. So in terms of our strategy, as we rolled our SSDs out, we have what we call a fleet management strategy at Intel. And what we're doing with the devices is we have very much a hands-on approach to the SSDs. We had an install base of laptops, and we had SSDs that we were buying, and so we were pulling drives in and out as we were migrating data and doing things. And we actually have kind of a hands-on approach with our devices today that we're rethinking, where, oh, you need more memory, we can stuff more memory in your system. You need a different capacity drive, we can stuff a different capacity drive in it. We're looking to shift back to a low-touch environment, and Ultrabook's going to help us there because it's much harder to open those chassis to where we'll buy the system, the drive that will remain there for the lifespan of the PC. And this coincides with our general PC refresh strategy, where we just have regular refreshes of the environment to maintain total cost of ownership and the platform performance. From our perspective, we like a single supplier with the SSDs. We do have a bit of a vested interest. We are Intel, so we do prefer the Intel drives for a number of reasons besides the fact that we're Intel. But it did give us a common supplier, which really simplified our engineering and simplified our support structure, because for spares and for other things, we had one basic platform to engineer and integrate to. And we had common tools across the devices. If we have different brands and types of SSDs, we would then be faced with, oh, I got to do this for this drive versus that for that drive. We also have some PC policies that impacted us as we move forward, especially with the hard drives, where we have a policy that we have, which is no hard drive leaves Intel. So when the system is ready for recycling or removal from the environment, our policy has typically been take the drive out, crush it. That was the only way that we could ensure the data was not at risk. We also do data wiping if we're reusing drives as well. So we've been working with those policies to see how we're going to adjust those moving forward, taking advantage of some of the things like the quick secure wipe capabilities of software that Intel SSDs offer. And as I indicated, we're very focused on the financials, total cost of ownership. And so all of our decisions in terms of the right capacity, when do we introduce these into the environment, how quickly do we ramp up, have all gone through financials. We've taken the drives through our security gauntlet, so to speak, where they take pretty much everything that we deploy as a product and they run it through, well, can I get data from this if there's an investigation? Can I recover data off of this if there's some really nasty event that's happened? So we've had to adjust to that and make sure that's built into our deployment strategy. We've also looked at the total cost of ownership as we've adjusted our support actions and what we do with the drives. One of the big advantages we have with SSDs is data transfer is a lot quicker. So when we're doing things where we have to migrate data and other things, throughput time is very, very fast. Gets people in and out of our PC service centers a lot quicker, saves us money on technicians, keeps the employee much more productive. And again, this wasn't an easy one. We do take employee and management feedback feedback on what we offer. I don't think we've gotten any complaints in terms of offering SSDs as a capability. So that's one of those real easy check marks for us. So from an operational experience perspective, as I indicated, these are much faster. They're much more reliable. They don't break as often. They're much more stable, fewer blue screens across the board. They're much more reliable. So we have them coming in. We have system issues much not as often. And when there is an issue, we have a much quicker turnaround in terms of fixing things. We did figure out how to deal with the different form factors. We do have to manage inventory and manage that across devices. Things have been pretty stable the last couple of years with 2.5-inch drives, but one of the things that we did discover is every manufacturer, has a different height that they want to have in their PC to have it fit in and support, and they've really been designed around hard drives, not SSDs, so they've got rubber bumpers and other things. So you have had to deal with that and make sure we have the right parts to go ahead and substitute drives in and out. From a data recovery perspective, one of the things that we have had to reiterate, that's a good thing to reiterate, is you got to back up your data. We provide general full backup capabilities in the cloud for all our employees for their work. And we just continue to poke on, you need to make sure that that's up, running, working, and your data is secure, because it's a little bit different to try to recover data off of an SSD that something's happened to versus a hard drive. So those hard drive tricks where we can get data off of them, they don't apply to the SSDs. So we had to do things differently there. But again, it's part of our overall message that your data needs to be backed up in the cloud anyway. We can get quicker recovery and less downtime. Again, firmware updates as we were deploying relatively new products. There were a lot of firmware updates in the early days. So we kind of went through that because we were early adopters with this. But as the products matured, the updates became much less frequent. And so our process today is you get a new drive, we just update the firmware when we get it, and then only touch it when support touches. So we don't have to do it down the wire and while the PC is being used. And we've also enabled it so employees can self-update, and we use the Intel SSD toolbox or the SATA SSD firmware update tool to do that. Generally, they don't have to, and we tend to bring them in the PC Service Center if there's some major thing where they need to do this. So at this point, I'm going to hand over to our technology evangelist, Doug DeBetter. Just a little more detail.
Thanks. So John is the strategy guy, the money guy. I'm his technical advisor or cheerleader for SSDs within Intel. All the questions of every time I come to John and say, hey, we need to go buy these, we need to provide these for the employees. He asks me why, what's it going to cost, what's it going to provide for the employees. So over the last 4.5 years, we've answered a lot of these questions. We always started out with a process of, starting small, doing paper research, doing pilot deployments, larger deployments, large-scale deployments, production deployments. Now we're at the point with 93,000 drives deployed for a long period of time. We can actually look at the data that we're getting from our deployments. So that's what I hope to share with you. I'll share some of the details of our research over these different topics. I really want this to be impactful to you. So if you have questions on, SSD adoption or technical questions regarding them, please fire away. I can talk to any one of these topics for a really long time. I'd rather talk on one topic of your choice.
So do you want questions now?
I would love questions all the way throughout.
How do I use that?
Bring it on. Just holler it out and I'll repeat them.
Okay. So I have two questions. There was mentioned earlier about two encryption techniques you're using. You said one was whole disk encryption. The other is hardware encryption. What's the difference between those? That's the first question.
Great. So the question is the difference between hardware encryption and whole drive encryption or whole disk encryption.
Yes.
We'll talk about that in a bit. I've got a whole slide on that. So we'll actually talk about that in depth, including a custom solution that Intel developed to deploy hardware encryption.
And the second question is, What's the advantage of self-encrypted SSDs versus self-encrypted hard disk drives?
Awesome. So what's the advantage of self-encrypting SEDs or SSDs versus self-encrypting hard drives?
Right. You indicated there was one.
Also, I'll get to that. You betcha. So from a performance perspective, I've done hundreds, if not thousands, of performance tests. I could have showed you pretty charts showing X% faster or whatever, and I want to take a different spin on this. Our perspective, what performance means to IT, is that I used to walk down the hall and get attacked because people hated all the stuff, the IT load we put on our PCs, and now they all give me hugs. Are there any Intel employees in the room? You can give me a hug after the session if you like. So we used to really burden our systems with the manageability agent, updates, backup agent, network backup agent, the antivirus. We used to have virus scan Wednesday. Wednesday at noon, full system scan would kick off on your system. Wednesday at noon was a very busy time in the cafe. People would get up from their desks and go eat lunch or get out of the office because their PC was rendered unusable. The most amazing thing to me is we have this same load on our system. We have higher demand than ever before. We have encryption software, a combination of software and self-encryption on the drive. And these systems perform. These processes, these agents run without special engineering. We used to have people that were dedicated to doing a custom defrag. They would defrag and specially place files on your drive for the optimal performance. They would configure the way that your drivers and apps loaded and boot up, optimize these things. We've abandoned all that. We don't need to do that. The system performs, and that's what makes me proud as I walk down the hall. The employees love it. They're fast. They feel the difference. So a chart, 4x, 32x, whatever, you're going to have your own characteristics in your environment. But the bottom line is, in our environment, our employees are a testament to them performing. They love it. Here comes the next one. So here's the beginnings of your data. So reliability. We published a white paper last year. We updated it this year. The links are in the back of the presentation that you can get. So reliability is the key to our total cost of ownership. We're averaging less than a 1% annualized failure rate on our SSDs. We did a study back in 2008 of our 2007 hard drive returns, and we had 4.85% annualized failure rate on the hard drives. So we're thrilled with this. We actually did a very detailed failure analysis on all returns. Anytime there was a returned SSD, we consolidated it to a central location, and we did a detailed failure analysis. As Brian mentioned, we've partnered with them. They gave us custom scripts. We analyzed the drive to determine the cause of the failure. We provided that data to them. So this was done on the early X25M series drives, and a lot of the learnings out of the analysis on that series of drives has been applied to the 320 series and later generations of drives. So the fact is, here in our environment, they're failing less. That's a huge benefit to the employees from a convenience perspective. It's saving IT money. The fact that they fail less is that big differentiator or the payback for that additional investment in the drive. All drives across the enterprise that have been deployed from 0 to 4.5 years. It's only looking at the X25M series, the second generation X25M post-build series. And the reason we chose that is because it's the first series that we broadly deployed, and we had a large deployment. I think we had 60,000 of them, 65,000 of them peak. And so we looked at that family only, and that is what this study is based on. And again, the details are in that the paper there. The thing that I'm most thrilled about, I love working with our product groups. I love making our employees happy, but I'm thrilled that the data that we collected from the analysis has gone into improving the 320 series and later generations of drives. So we're expecting that the annualized failure rates are going to go down. We've actually stopped doing detailed analysis on failures and providing that feedback. We've got it up. We're convinced. Right? They fail less often. That's great for us. Boy, I can talk a long time. I'm sorry. Going slowly here. So drive wear. Will the drives wear out? What have we done with regard to analyzing this? Very valid question. We had the same question when we started. Are these drives going to last? When we put an SSD in our laptop, is it going to last for the life of the laptop? What we're seeing is that they actually last well beyond the life of the laptop. We've got drives that we've taken out and we are redeploying. So maybe we buy a new system with a 120 gig drive. The employee had a 160 gig drive in their last system. We take it out and we move it to their new system. The drives are lasting well beyond our wildest dreams. So we have the ability to look at and pull smart data from our systems deployed at Intel. And Intel defines the E9 attribute of smart as a wear indicator on the drive. So we can go down the wire, look at the life expectation on the drive. And I did that recently. Across our 93,000 drives, I was able to quickly and easily get data off of about 80,000. So it's not a perfect, but it's a pretty good sample. Of those drives, 98% of those drives had 90% or more life remaining. Again, these are drives that have been deployed from 0 days out to 4.5 years. So I couldn't tell you which one exactly, how long each drive has been deployed. But what I can tell you is I'm convinced that these drives are going to last well beyond the 2, 3, 4 years that we're expecting of them, on a whole. So Intel estimates a 20 gig a day guidance. We've done detailed studies many years ago where we're looking at the actual read-write volume of a select group of users, and we were seeing much less than that. And it's, again, going beyond to our full population data. We're seeing data that confirms that these drives are going to last well beyond the life cycle of the asset. So this unplanned benefit, something that also didn't go into our TCO calculations, is that when the laptop is being refreshed, we can pull the drive out of that laptop and move it into a new generation laptop. Or we have been actually deploying them in desktops, labs, or special projects. So we're getting extra value. This is work, additional work, and it comes from managing the SSD separate from the PC. It's not right for everybody, but in our case, we're getting extra value, extra life out of the drives because they're lasting. Yes.
Can they be formatted and permanently erased?
Can the drives be formatted and permanently erased? Yes, they can, and here's a few ways you can do it.
There's no quadrants.
So the question was, can the drives be formatted and permanently erased? I'll actually talk to that on the next slide. But one way you could wipe drives is with the tool set. So one of the items that's been good for us, IT, within Intel, is the tool support that's provided with the Intel SSDs. Something that, again, we didn't think about, but it has come to be a differentiator between ours and other brands. So there is the Intel SSD toolbox that's available. Employees can install it, look at the health of their drive. They can look at the drive health and estimated life remaining. They could do a secure erase. They could do a firmware update. Again, as the IT guy, I don't want my employees to have to worry about this, but we work in a very technically savvy group of users. There are people that want to get their hands dirty. They have a tool to do it. This capability of the SSD toolbox is provided to you free from Intel.com. In addition to being a graphical user interface, there's also a command line interface. That's something that IT said, I can't use this if I have to pop up an application on a screen and have people click. So all the capabilities that you can do from the graphical user interface, you can also do from the command line interface, so you can do them down the wire. The Intel SSD firmware update tools, again, available from Intel.com. That is what we use to update the firmware. So we do firmware updates on significant support touch. If we do a new deployment, or if we're going to rebuild a PC, we check and make sure that the firmware is updated before we deploy them. So we use the tools from that Intel provides along with the drive. The data migration software is a free cloning software. And then the bottom, the Intel SSD solid state drive 320 series TCO client estimator is a web page where we've taken the analysis that we did back in 2009 and revised it over time. And we've made our assumptions and estimates available to you in an online format. You can put in your own numbers and see how the numbers work out for you.
Does the toolkit only work with Intel SSDs?
The toolkit only works with Intel SSDs, yes. Yes?
So this actually is a full secure erase, not the crypto erase.
This is a full secure erase, the ATA security erase unit.
Okay.
And the different drive families implement either secure erase or enhanced secure erase. And my understanding of the difference is one wipes the drive, another wipes the key of the encrypted data on the drive. Another thing that we saw with regard to secure erase is that on the early drives, there are potentially reallocated blocks that were marked as bad, and it doesn't wipe that. So on the early drives, if there are reallocated blocks on the drive, there might be fragments of data remaining. That little bit of might be and maybe is something that our information security folks don't like to hear. So we probably wouldn't resell those drives. We'll probably chew them up.
But that's not true of newer drives, right?
Newer drives with the enhanced secure erase wipes retired blocks also, and spare space. Okay, encryption in depth. I'm going to fly through this pretty quickly. So here's our experience with software-based full drive encryption. The difference between software-based and hardware-based drive encryption I'll get to in just a second. Software-based is when you have software installed on your laptop. All I/O goes through an encryption algorithm processed by your CPU. That has inherent delays and slows things down. The great thing about software-based encryption is it encrypts everything on the drive. It works quite well, and it provides enterprise management. Enterprise management allows us to manage passwords and provide IT service to help you reset a drive or unlock it if you forgot it. The big thing, other than just sort of a general overall performance issue, is the thing that we saw was a time to resume from hibernation. Could take twice as long with software-based encryption. Don't quote me on that number of twice as long because it varies based on what drive you're using, PC you're using, software encryption solution you're using. But the bottom line is software encryption adds a load to the PC, and it impacts the user experience. So our info security folks loved it because our data is protected. Employees, not so much. So on comes the Intel Solid State Drive 320 series. And this also applies to later generations, the 520 series that you've probably heard a lot about. I call it the 320 series because when we started this a year plus ago, this was the drive. But it provides the reliability and performance of the prior generation drive, plus it adds AES 128 encryption. This is done by the controller. It's no performance loss when it's done. Everything that is written to the drive is automatically encrypted by the controller. Read from the drive is automatically decrypted by the controller. The data on that drive, or that encryption and decryption automatically by the controller, is locked or enabled by setting the ATA user password through the BIOS. So if you go into your BIOS, set the user password, that locks the encryption key, and only once you unlock that drive will the controller say, okay, I can start reading and writing that data. So once your data is at rest, you take that drive out. The data is encrypted with AES 128. People can't pull the chips off and read data. Right? We're believers. Same thing. We've been through security vetting, internal, external analysis. We've had people try to read data on an encrypted drive, and it works for us. So this gives us the hardware encryption over software encryption. The CPU is not doing the work. The drive controller is doing the work. So the performance is back. The state transition time is back. And there's no initial time-consuming and problematic encryption process. With software encryption, you start the encryption process. It has to read all the data off the drive and relay it down encrypted. Once you set the user password on the drive, it's locked. So it's instantly done. Yes?
Is this OPAL compliant?
Is this OPAL compliant? No, it's not. And that's a great question. What's the problem with it? The problem is there's no enterprise management. How do you manage the user passwords? So a user goes out and sets the user password through the BIOS, and they forget their password. What do you do with it? IT can't help them. What happens if the user goes in and removes their user password, and all of a sudden their data is not protected? So enterprise management allows you to enforce policy, password strength requirements. It allows you to require the user to have the password set. It allows you to help reset passwords. So enterprise management is the missing piece. And so we take the self-encrypting drive. It has no encryption, or it has no enterprise management. This is our encryption journey. We start way over here with our software-based encryption in 2009. In 2010, we have software-based encryption with AES-NI. Those are CPU instructions that help the performance of software-based encryption. Things got a little better. In 2011, we started deploying software-based encryption with AES-NI. We also started deploying the 320 series drives. When we started deploying the 320 series drives, we were deploying them with software-based encryption put on top. So people started asking me, and I started asking him, hey, if we're deploying the 320 series, how come we're not getting rid of the software-based encryption too? And it was because of that management. So here's our quandary. Do we deploy hardware-based without management or software-based with management? And so here we are, and our long-term goal is an OPAL compliance solution. OPAL compliance, for those of you not familiar, means that you have the hardware-based solution plus the management. Right? So that's the vision. And that is coming. It's new. We expect it to start maturing now over the next few years. But what do we do in the meantime? And so this meantime is this big decision point. And so what we did is we developed our own management solution. So we are now removing software-based encryption from the drives. And on the 320 series and 520 series drives, we're using AMT to reach out to the system, and IT sets the user password. So there's a local user app. It's all web service based. So there's a local user app. There's a web-based app. There's a web app that the IT support folks can get to. And what we do is we reach out through AMT serial over LAN, and we set the user password. In addition to just setting the user password, we also set the master password. The master password is what gives us a little control. So the user will create the password using the application, the front-end application. We make sure that it meets password strength requirements, and once it's approved, we say, hey, set this password on my drive. The back-end engine reaches out to that PC using AMT. It shuts down the PC, it boots into the BIOS, sets the user password, sets the master password. The master password is only known to IT. The user password is only known to the user. So it gives us the appropriate levels of control. And then we have a record of that registration, and we can provide support. So that's the solution that we're providing. It's a little bit kludgy, it's a little bit extra work, but it's pretty cool that we can do it out of band using AMT to interact with the BIOS to set that user password. It gives us full remote capability to help support that user password on the BIOS.